Okay. Hi, everyone. It's nice to have you all here. You're welcome. You're welcome. I am Happiness and I want to welcome you all specially to this meetup. Okay, so just to start, today we are going to be talking about designing explainable AI agents people can trust. And specifically, I'm going to be talking about why trust is the real AI bottleneck. So I would like to share my slide so that we can all see. Like I said, welcome once again to this meetup. About me, I am Happiness Omale. I'm a Lamatic AI ambassador, a data scientist, and a technical content creator focused on making AI easier to understand and use. I build AI agents, but more importantly, I focus on making them explainable, practical, and easy for humans to trust. And then through technical writing, live demos, and community events, I help bridge the gap between what AI can do and how people actually use it in the real world. I'm also passionate about community, knowledge sharing, and helping more people build confidently with AI. So, like I said, I'm going to be talking about why trust is the real AI bottleneck. So, as we all know, AI is making more decisions than ever. AI is everywhere. AI is operational now. From loans to fraud check to hiring to trading, even customer support. But people always get this problem. We don't always trust why it's making those decisions. The blacks the black box problem. Most AI systems work like a black box. Sometimes you put something in, the answer comes out, but you don't know how that answer came about. There's no clear reasoning, no transparency, no accountability also. And then we have the real world risks. When you put something in and it gives you an answer and you don't know where the question or the answers are coming from, it gives risks. So when AI can't explain its decisions, people are afraid to use it. Businesses are also afraid to use it, and users stop trusting it. People really trust systems that explain the reasoning behind them. So even in finance, in healthcare and operations, you can't just say AI said so. It is not logical. You always need to give reports of how this AI thinks. But with that, there's a shift happening currently. We're moving from static AI outputs to reasoning AI agents that think, justify, and communicate decisions. And there's also a way forward. So, like I said in this slide, to solve this problem, the AI industry is now focusing more on proof and transparency, not just how smart the AI is. This include RAG, making AI show where it's got its answers from. We have human in the loop. That is like designing AI to support human decisions and not replace them. And we also have law regulations, law like the EU AI Act that sets safety and accountability standards. So why this matter? Why we need trust? When there is trust for your AI product, there is better adoption, decision confidence, regulatory compliance. So the question now becomes, how do we actually design AI agents that people can trust? We really need to understand that trust, and that is why we are here. So, to understand that, we are going to be having our speaker, Dhruv, who is going to talk to us and tell us about all we need to know about trusting AI agents and creating an explainable AI agent. Anyways, before Dhruv comes up, I would also like to give a brief introduction about Dhruv. So, Dhruv works at Lamatic AI, where he focuses on building practical reward AI systems and agent workflow. He's also the co-lead of the AI Collective Daily, a growing community advancing conversations and learning around AI. Dhruv holds a BS in Data Science and Applications from IIT Madras alongside a BSc in Mathematics from Delhi University and is affiliated with the Institute and Faculty of Actuaria. With a strong foundation in machine learning, deep learning, and applied AI, he is passionate about building scalable AI solutions and contributing to projects that drive both technological innovation and real businesses. So now I would call on Dhruv to walk us through how we can build an explainable AI agent. Hi, Dhruv, you have the floor.
Thank you. So, hi everyone. I'll be speaking about designing explainable AI agents which people can trust and how to build them, how to structure them. So, can we have my screen up? I have a presentation ready. Yep. Designing the presentation which I'll be giving today is designing explainable AI agents people can trust. So, the whole concept here is that we build with transparency, accountability, and reliability into agentic systems. So today what happens is that everyone is building AI agents from ChatGPT to Claude to even companies such as like like even with NA10 and other companies, they all are offering AI agents ready and templatized. But one major problem, or basically the one core problem which divides into two sub problems is that nobody trusts them. So why does nobody trust them? If we are to categorize that in two sub problems, which would be the major cause, it would be the black one of them would be the black box problem, and the other one of them would be a core tension with AI agents and how much access do we give them. So with the black box problem, as we can know, a lot of the AI agents today are just one big prompt slapped into the agent, and not technically a zero shot prompt, a multi-shot prompt, but a singular prompt, a monolithic prompt, which decides everything, regardless of the model or the specifications or things which the model excels at. It does one single agent does all the thing and decides and gives the answer without verifying its sources, without explaining its thinking, its thoughts and processes. And in that, what happens is that the prediction of when it will fail and how to audit it becomes very, very difficult because everything is stored in that black box and it is not deterministic in nature. So that is one problem. The second problem, which be how much autonomy should we give to the AI agents and how useful it is. So now to build AI agents, one thing which is like a given is that we need to give it autonomy. We need to make them self-sufficient, but autonomy without transparency can destroy trust rapidly. The question isn't that can we build powerful agents in today's day and age? Of course we can. The answer is, can we build agents people actually use and rely on in production? Can we build agents which actually matter and save us time, cost, as well as give us high quality outputs? So if I have to design a framework or three pillars of trustworthy agents, it would be in these three categories. One of them would be explainable routing, where basically we decompose routing in a structured and deterministic manner so that it's auditable at each point. Every classification, supervision, and branch is visible and traceable. So rather than keeping everything in one prompt and all the decisions in one prompt, we break it down into branches in such a way so that we can audit it back at which decision was taken, why was it taken, and then we can fine tune the prompt as things move ahead in production. Second, forced clarification over guessing. Now, many a times we have been using Perplexity, Cloud Code, and other agents The agent stops, it asks us questions, and then it moves ahead. It may sound very unlike agentic automated applications, which does everything on its own, but it is much better that an agent asks you before it assumes information. There are low stakes or low lift tasks which do not need that kind of clarification. But when we move into the real world, it is an assumption can grow grossly wrong. The worst case scenario of an assumption going wrong can be wrong information relayed to the customer or to a professional in high stakes professions such as legal professions, finance professions, etc. So it is much better that it assumes. Think of it as a research librarian. You would much rather want a librarian to ask you one or two questions before just handing out a book straight to you. Now, the third point would be grounded generation with provenance. We should retrieve all the information first asked and then synthesize it. Whenever a question is asked, it is much better that we retrieve information, and from where, like from the internet or from internal resources or from scraping external resources, that can be decided. But the whole point is that whatever has to be done, the retrieval is well thought of, well processed, and it is well collated. So that when the final generation happens, it happens on truthful and authentic data, which can be always cross referenced, rather than the agent just getting a faulty RAG context or a faulty context and it just assuming things based on that context. The agent is more of a guide and not the primary authority on your final answer. The primary authority would be the context on which the answer is built. Now, the architecture or the patterns that enable trusts can be classifier nodes or classification methods where each decision point is not buried in a single prompt. It is routed and it is a visible route. Think of it as a graph where the parent node clearly structures decisions on child nodes, and you can see it moving and why it moved to that particular child node. The final answer can come through multiple graph iterations, but if we are able to trace that why the parent chose that decision, that can be very important. Single responsibility stages. Now, each path should only handle one kind of responsibility. With today's day and age, we have models, we have models which are good at certain tasks and not so good at other tasks. So instead of keeping one high-end model which can does all which does all tasks on a above average level, it is much better to have multiple models or multiple data points which perform very well and collating them via this graph structure where the parent node decides what task to give to the child. The child node executes it and relays it back to the parent. The parent node orchestrates and collates it. Now, parallel retrieval is also a pattern where whatever information you want, you search for it extensively and through a hole. You prepare for comprehensive grounded coverage, which can always be cross-referenced. So it should not just be information from a random website or a random data point. It can be information which is grounded, authenticated, and can always be verified either through internal resources or if we are going for external resources. It is important that we always have a source that where was this taken from. Next is first class guardrails. Now, many a times it is important for us as the designers of these agents to define guardrails very, very clearly. There are many a times where you move things into the production and you realize that people are using the product in the agent in a certain way or asking questions which are not ideal, which can be out of scope or downright harmful to the agent. The agent can make more assumptions. So it is better that we define guardrails clearly before the agent is put live or before the graph is explicitly defined in production. Of course, the guardrails can be more defined as more users and more output comes in, but it's important that we give extensive thought on guardrails prior to deploying the agent live. Structured response modes. The system, whatever answer the agent gives, the agent should also clearly tell at what stage of this answer is. Either it's a thinking question or the agent is wanting to get more information from the user, the agent is actually answering and it's giving you the final output, or is it just saying that this is out of my scope and it's just blocking the request? Whatever the agent thinks or wants, it communicates honestly to the user, and our system or UI displays it like that. So today's case study, what we are going to be seeing today, is the legal research agent. It is a multi-stage conversational agent that helps lawyers or people looking to explore case laws and statutes based on based on US law and built on Lamatic AI to demonstrate all the three pillars of trust in action as we saw. The data points that we have referenced are case law indexes from the Supreme Court, from the US Supreme Court, statute index, legislative text, sections and amendments, and legal glossary from the US government website. So all of these three data points are valid and authenticated. So this is how our agent's pipeline would look like. Whenever the user query comes in, the classifier understands, reads the query and understands what kind of query is it. Either that query can be one of these four options as we see. The first type would be question clarification, where the agent wants to clarify more on the question from the user. So basically, that means the agent wants to inquire that is this the question that you're asking? The core fundamental of the question that is handled by this model, by this path. The next path is direction clarification. Once the classifier sees in the chat history or in the conversation that I have enough information about the question, now I need the direction to take this question to. A question can be answered based on practical references or based on theoretical references as well. A question can be answered based more on empirical evidence or based on terms of more theoretical evidence. So we put that. So just to clarify that, we have the direction classifier. Next, but before that, we'll go from this one, the guardrail breach. We clearly define that, okay, if some question is breaching a guardrail or it's not an ideal question, you straight away put it here and it ends the conversation there and then. And it tells the user that this is out of my guardrails. That is why this is in red. The part where we use the query composer is where we have the question and direction both clear. And now we want to compose a query or we want to compose a text which can parallelly retrieve whatever the user wants extensively from three different databases or multiple databases or multiple data points. We do parallel retrieval and we collate it as one singular context window with clearly defined that which database it is coming from. And then once we have all this information, we give it to a proper LLM or a model which can generate answer based on citation and links. So this is how it would look in action. The user can ask a question. First, a question clarification would happen. Question clarification would happen. It would explain that what is this the question that you're trying to ask. Once you confirm that, it'll try to ask you direction, that what direction do you want me to take this question into. And once it has that information, it can finally answer and retrieve. So before that, I want to show how it works in real. This is a UI we've built on top of our agent. I think first it is better that we show you the agent itself. So this is how the Lamatic agent looks like. So this is the API request where we can have the chat message and chat history stored. And this will how we enter this agent. Well, after some processing of the history to clear it, in case of new queries, we move to the classifier. Now the classifier has an extensive prompt and it tells that what are you supposed to classify a question as and what the rules are of breaking this into sub-parallel paths. Think of it as us defining the parent node logic. This entire graph, this entire prompt defines the parent node logic. Now this has to be the most extensive prompt or the most extensive explanation of what you want the agent to do. And yes, of course, it cannot be a zero-shot prompt. It has to be a multi-shot prompt with explanations. You define everything, you tell it when to move to a certain stage, you define how user can talk about certain like assumptions which you might have to take and how you have to take them. And then you clearly also define, as you can see, some guardrails as well. Exception, explicit rejection. And in your inputs, you define the classifier and you can just tell it which four subpaths are there. So here we have the question clarification prompt. And one more thing before I move to this. This classification prompt is being done by a model which has a good quality output. So if you see in Lamatic AI, you get all these models and you can see what kind of model do you want to choose. A cheaper and preferred model, a faster model, or the best quality model. So when we have a best quality model, we can gain more we can be sure that it infers subtle human text or it understands context way better than say a GPT-4o mini would. Here we have the question confirmation. This is a simple prompt which just tells to clarify the question and what the user is asking for. And for this, you can use a smaller or like a faster model like GPT-4o mini. Similarly, you have the direction confirmation. This does exactly the a portion. This is exactly designed like how the question confirmation one was, but this focuses more on the direction. And once you have all this, you have an expert clarification. Once the agent decides that I have information on this and this, it moves to this. The expert clarification again does the query composition end to end, and it says that okay, this is what we have got from the past two stages. Now define it into one singular query which can be made useful for all data sets. So it gave an answer something like this. So it's collated all the information, the way it has to be retrieved, and how you have to structure the question. Then we add a branching logic in Lamatic, and then we pull information from all resources. This can be indexed inside Lamatic itself from multiple data sets with with different metadata. So you don't have to worry about matching metadata and all those things. You can just quickly search from all these vector databases from your embedding model, get the number of vectors you want, and use filters if need be, collate the references, and then get the final answer. Final answer again should not use like a quick fast model which gives a substandard answer. Here you can again use a higher model which knows how to write well, which knows how to structure answers well. And the prompt here again would be a bit more refined than say a question clarification or direction clarification prompt would be. So if we have to see this in action, there's a small UI built on top of that. So let me just ask this question: what are my rights when arrested? So here we see it has first asked me for a question clarification, and it instantly prompts me to move and answer the question. So if I would say I would like both. So I don't need to necessarily mention it again. I can just mention what I want and it'll understand automatically. Okay, so now this is asking for the direction confirmation. So now that we understand that it is thinking more, so it finally has got all the question clarification and direction clarification. It is now synthesizing the answer. It is searching for for the context in vector databases, and it is searching and it is collating the answer based on that. Now, the vector databases not necessarily need to have information which you have to manually index. This comes in case where you are indexing internal information. When you have information where, let's just say, you want to search the internet or you want to scrape a website, Lamatic also has option for that in terms of Firecrawl node and Serper node. So now we see when the answer starts, when it has designed, it will start streaming the answer as it is. And now I can see it's giving me an overview, a legal definition with glossary results from the glossary database, landmark cases from the Supreme Court, and it is referencing each case, and statutory framework. One interesting part here is that it always references where it is getting the answer from. So it is not, there's nothing based on assumption. Even if there are some assumptions or interpretations, the agent is going to outrightly say that this is what I assumed based on this, and you can go and check it. So if I see the definition of warrant, yeah, so we move straight to the United States Code website and we can search for it there. If I see for this case, which it has referred, we can straight away go to this case and we can read more information so that we know that this information is being synthesized from something which is original and can be trusted. These need not be necessarily in information on websites. It can also be internal information and always cross-referenced for clients or people involved. So if we are to move back here, so this is why this agent or this framework particularly matters in serious domain, like in serious domains or enterprise domains. Trust does not just become trust and quality, I should say, is not an optional thing. It's not something that the users can compromise on. If the agent fabricates a legal citation that doesn't exist, like for take this exhibit for example, it's not just technically a failure, it's a violation of user trust in a domain where accuracy determines outcomes. Legal interpretations can determine what a person does or references back or understands of a certain law or a right. That is why it is important that information is always cross-referenced, valid, and the agent clearly explains what it is looking for. Similarly, in scholarly cases where academic texts and their interpretations can mislead researchers, and it has a cascading effect. Same thing in enterprises. One bad answer can actually kill months of trust for a customer. So in each of these cases, you see that trust or quality is not just like an optional thing which derails the user slightly. On best case, that can be the scenario, but in worst case, the it can just basically it has a cascading effect where it can make things seriously go wrong if not taken care of. So this is again under the hood what we are doing, like as we showed you. It's using GPT 5.2 for routing and 4omni for clarification. Generally, you can also interpret this in mind that, and like while you're designing the agent, you have to choose the model in terms of what are its specifications, what are the things that it excels at, and in terms of what are the things that it can do much faster and cheaper. You have to take these two things into account, because regardless of how good an agent is, if we're not balancing between cost and time, we don't want to be making an agent which is very good but then it takes $1 to in one iteration run. That does not make sense. Again, it should take max 2 to 3 clarification turns so that it understands and then it synthesizes the answer. It is much better. Like even if you ask perplexity, you would want that the perplexity understands in 2 to 3 prompts and it answers a 80 to 90% accurate result, than it taking 10 or 15 turns and then answering exactly what you want the way you want it. You can prompt it better and eventually get to where you want, but you don't want to be spending 15 or 20 minutes with an agent just to get one answer. It is much better that you spend a shorter time and do multiple iterations until you reach exactly what you want, based on assumptions as well. Parallel multi-index search, as we saw, we can search from multiple data sources, both internal and external, so that, and then collate them all into one, so that we don't tell the agent necessarily that okay, you have to now do this, you have to now do that. In Lamatic, you can have the data indexed, and you can data retrieval can be a completely separate process, which can be much faster than an agent calling a tool which gets the data back. Parallel multi-index search, is there every citation or everything is a hyperlink. So in our answer, we're always cross-referencing the answer. The user should not necessarily trust the agent blindly. It can trust the sources that they can verify manually themselves. So if I have to sum this entire thing up in one line, I would say that agents people will actually use in production aren't the agents which sound the smartest or are the most fast agents. They're going to use the agents that know when to ask, know when to stop, and always show their work. So this is how you primarily this. If you keep this entire line in mind when you build agents, I'm sure that you'll be able to build some agents which can actually be used on a large scale and which you can also trust and rely for your own outcomes. So yeah.
And you can follow Lamatic on LinkedIn. That is the LinkedIn URL right there.
Yeah. So you can sign up, as Happiness said, you can sign up on Lamatic. You can ping me on Slack or GitHub or LinkedIn. You can reach out to me personally if there are any questions or you want to a walkthrough. We are always happy to take you through it.